Video is about how to find percent error, a very practical use. You may have done this in science. There's a formula that is given on your formula sheet for percent error, and it's the approximate value minus the exact value over the exact. The other way you might see this for percent change is the original minus the new over the original. The key is always making sure you find what the original or the exact is, and that's your denominator. Otherwise, your measurement will be off. So measurement of 5.392 was rounded, so there's the approximate value. So 5.39, the exact value is 5.392. And we divide by 5.392. So you're always making sure, and it's absolute value, so you know if it's an over or underestimate by looking if it's bigger or not. But the only other thing to be careful of is when you do your subtraction, 5.39 minus 5.392, make sure you put the numerator in parentheses, and then that you divide by the exact amount. So this is a very small amount, negative 3.71 times 10 to the negative fourth. So I'm going to change that to a decimal so I can change it to a percent. So 3.71, I'm going to move it over 1, 2, 3, 4 places. So the actual number is 0.000371. That means the percent error is, to change a decimal to percent, you multiply by 100, so you get 0.0371. And it's absolute value. So that's the percent. Always label at the end. Okay, the second one here, selling pixie sticks on 3rd Street. This is actually a true story. Mr. Moore is always selling pixie sticks on 3rd Street. He thought he made 125, he actually made 118. So the percent error is 125 minus 118.3 all over 118.31. And again, the numerator really doesn't matter which order you go in. The key is that you divide the denominator out. But and try to keep it in the same order so you can follow your formula. So parentheses 125 minus 118.31 divided by 118.31. 0.0565, and that's before we change it to a decimal, or to a percent, so we move it over 2 places, 5.65%, and that would be an overestimate. This would have been, we estimated this one to be a little bit smaller, but didn't ask that in the question. Okay, so I'm going to go ahead and go to the back of this page. These are not all percent errors. There's some other parts of it in here as well. The wheel of Mr. Kirchner's bicycle has a radius of 13 inches. Okay, and so we could find the perimeter of the wheel and the area of the wheel. How far does Mr. Kirchner's bicycle go with one turn? So we're going to use 22/7 for pi. It just says so. We're not using the pi button. You could also use the pi button. So one turn is a circumference. So circumference equals pi, so 22/7 times the diameter. So if the radius is 13, the diameter is 26. So 22/7 times 26. 81.7 inches. So every time a tire turns, 81.7. It says now convert your answer to feet. So practicing some dimensional analysis. This is the way I do it. Some of you have learned a proportion. which is okay unless you are moving multiple units. So I like to show you this factor label method. Put inches here, put feet here. Notice I didn't write any numbers in. I'm just looking at what units I want to cancel out. 1 foot equals 12 inches. So I know I'm going to be taking 81.7 divided by 12. So 6.81 feet. It may be hard for you to think about that one turn of your bicycle tire goes 6.81 feet, but it does. It's 0.485 miles from Mr. Kirkton's house to the school. How many times will his bicycle wheel rotate? So for every rotation, it's 6.1 feet per rotation. And we want to know how long until we get to 0.485 miles. So what I would do to solve this is convert 0.485 miles into feet. And 1 mile is 5,280 feet. You can get that from one of your notes. You should know that. You live in the United States. You should know this. Even though we don't use everybody else's system, this is the system we use. So 5,280 times 0.485 means we're going 2,560.8 feet. And I'm just going to leave it more than 3 sig figs. So if one rotation is 6.81, we just divide this by 6.81. So about 367 rotations. And somebody asked me, I didn't talk about this in class, this little thing means approximately. Okay? Mr. Moore figured out the answer to A using 3.1. Okay, so what percent error is the rounding? So the circumference, instead of 22/7, it'd be 3.1 times 26, which would be 80.6. So his estimate was 80.6. So percent error, we're going to take and subtract, we're going to find the change. So it was actually 81.7, and make sure that you divide by the actual. That's the only thing that really matters. The numerator will go away. So 80.6 minus 81.7, and then divided by 81.7. So when we move this 2 places, that would be 1.35% error. And again, it's absolute value, so it's always positive. Song Sung Blue, everybody knows one, found the height of his friend to be 9.5 inches. He rounded up to 6 feet. What is the percent error caused by his rounding? Okay, so we need to do some conversions here from our crazy unit. So you either need to convert this to feet or convert this to inches. I think it will be easier to convert 6 feet into inches. So again, I write my units feet here, inches here, and I know 1 foot is 12 inches. So this is 72 inches. Over here, let's do a little figuring here. That's 60 inches for 5 feet. And then I'm going to add 9.5 inches. So 69.5 inches. So this is the rounded, this is the actual. So let's find the percent error. 72 minus 69.5 divided by 69.5. Again, absolute value. So parentheses 72 minus 69.5 divided by 69.5. And that would be moving it 2 places. So 1, 2, 3.597. The 9 rounds up, so 3.60%. Error. Ann works in a supermarket for $10 per hour. If her pay is increased to $12, then what is her percent increase in pay? So 10 minus 12 over the original amount. Okay, this is one of those values that you have to do as an estimate, saying we're percent change is the change over the original. It's kind of a different form of this. So 10 minus 12 is 2. 2 over 10, 1/5. That's a 20% increase. Don't even need to calculate. Okay, so this is just a little note, percent increase, absolute value of the difference divided by the original. Probably the biggest mistake made with that. Okay, a few conversions here that we need to have the specific units to go with that, and I don't have them on this paper, so this video is going to end. We'll pick it up with another one later.